Hello students, we are recording here a video about the lab number 5. In this lab number 5, we're going to investigate the relation between the period of a pendulum and the mass, the period of a pendulum and the length of the string. And also we're going to analyze, or we're going to learn how to find the spring constant for a rubber band. In the first part of the experiment, they ask you to investigate the relation between period and mass. So you have a simple pendulum here, that is in its equilibrium position, right? So to measure the period, you have to make sure that you're going to use an angle that is in the order of 8 degrees, 10 degrees, no more than that. Because when you have an angle in the order of 8 degrees, 10 degrees, the sine of the angle is equal to the tangent of the angle and is equal to the angle. So that's why we use very small angles, to make the study, of the period of the pendulum. Now, what are you going to do? You're going to move in this case, instead of a bob, you're going to use some washers, right? So you're going to move the pendulum away from its equilibrium position to approximately an angle of 8 degrees. You're going to release, right, the pendulum. And then one period is when starting at this position over here in the extreme right, the pendulum pass to the equilibrium position, go to the left completely, it's going to stop for a second there in the left, and then it's going to come back and passing again to the equilibrium position will be returning to the initial position. But of course, if you try to measure the time, with a stopwatcher, just for these for only one period, the problem would be, that you're going to have no very accurate value of time. So usually what we do is to find the time for 10 continuous oscillations, right? And once we measure the time for 10 continuous oscillations, we divide that value of time by 10, and that is going to give you the period of one oscillation. If you represent, the period of the oscillation here in a graph, what you see is, that your oscillations, of course, are following a kind of sinusoidal function. And the period here will be the distance from two maximums, right, that are in phase, right? So between these 2 points, you have a period. So this is called a period. So once you find the period, you will be recording in a table for 5 different trials, mass versus period, the mass versus period, right? So you change the mass, you are adding more washers, and then you find the period for that case. You add more washers, then you find the period for that other, and like that. And finally, you will be graphing a graph of period versus mass, right? Taking in consideration that according with the theory, the period does not depend on the mass. So imagine what is the kind of graph that you are expecting to get in this case. So the second part of the experiment is an investigation about period and length, right? So we're gonna investigate the period versus the length of the pendulum. So the length of the pendulum would be the length of the string, basically, in this case, we know that the gravity is equal to 4 pi squared times the length divided by the square of the period. So if you solve for the square of the period, you will get that the square of the period here is 4 pi squared the length, right, divided by the gravity. The equation we're gonna get here, when you graph, the graph is going to be in a straight line, so we have a linear equation where the expression 1 over g will be equal to the slope of the line. So if you say that the slope is 1 over g and you solve for g, you can say that g is going to be 1 over the slope of the line. Now, if you want to find in the gravity, if you want to estimate the value of the gravity experimentally, what you have to do is to divide 1 by the slope of the line you are going to obtain. But what line is that? Well, in this experiment, you're going to have 5 trials. So you're going to have 5 different values of length of the string, and you will find the period for each of these lengths, right? You can do exactly the same thing. You can just take 5 oscillations or 10 oscillations, right? And the time, for 5 or 10 oscillations, and then you will divide either by 5 or by 10, depending on the number of oscillations that you count, just in order to get more accurate data. Now, what is the next? The next, you're going to find 4 pi squared L. That would be the fourth column of this table, and you're going to square the period. And then you're going to use these two last columns of the table, and you're going to make a graph of 4 pi squared L versus the square of the period. You're going to get a group of points, right, on the graph, and then you're going to find the line that better fit all those points. Remember that the line doesn't have to pass through any of the points, right? The line is not obtained, just joining the first and the last point. That's a mistake, right? So you're going to look for the line that better fit all the points. That means the amount of points and the distance of the points that are above respect the distance, or the point below distance from the point to the line is more or less the same, sorry. So this is how you find, this line. So with this, you can find then, the slope of the line, and with the slope of the line, you can estimate the gravity. Of course, they will ask you later to find the percentage of error, of this gravity, comparing with the value of gravity that we are assuming as the correct value, that is 9.81 meters per square seconds. And then after that, we're going to move to the next part. The next part will be to determine the spring constant of a rubber band. So you will take a rubber band. They give you some instructions, about cutting the rubber band, etc. So what are you going to do? You are going to have your rubber band, and in the extreme of the rubber band, you're going to put a string. The initial length of the rubber band is the length without any washer hanging, right? Now, after that, you're going to start, of course, then hanging some washers, 2 by 2, right? You need to have 12 washers of the same size, or the same weight, so same size, same material. So all have to have the same weight. So the first you're going to do is to add 2 washers here. You're going to measure the new length, and then you will put in the table the displacement. The displacement is the difference between the length when you have 2 washers hanging, versus, right, or subtracting from that value the initial length. After that, for the second trial, you're going to hang 2 more washers. So you're going to have 4 washers hanging. You will measure the new length, and then you will find the displacement subtracting the new length minus, the initial length. And like that, you're going to obtain the displacement, okay, for the different number of washers. In total, you will have 6 trials. In total, in the first trial, you will have 2 washers. In the second trial, you have 4. In the third trial, you have 6. In the fourth trial, you have 8, and so on. Now, it's important, that, and they mentioned that when you are taking the measurements, right, of the length, you must find the standard deviation and the mean, right? Of course. So they ask you to take 3 measurements, and taking 3 measurements, you will then find the standard deviation using this formula. To find the standard deviation, you need to find first, of course, the mean, right, of the measurements, right? So once you have obtained the data, of the table, number of washers versus displacement, you're going to make a graph. This graph is number of washers So it's the same that the weight basically is a measure of the weight, and in the y-axis you have the displacement, and then you're going to get a group of points, of course, and you're going to find the line that better fit all those points, and the slope of the line that better fit all the points is going to be the spring constant. Oh, that means in this case it's going to be the constant of the rubber band, right? The elastic constant, of the rubber band. So this is basically what this Lab 5 is about. You don't have to use any simulation for this Lab 5. All it's about just only to be working with these simple things that we can have at home. So piece of a string, a rubber band, and some wire that you can buy at Home Depot or any other place, right? So it's a very simple experiment. There are very simple materials, right? You don't need to use any simulation to do it. So I think you can do a good report in this case. You can do a very good job. So thank you for your attention. I hope the video will be really useful for you. Thank you.